let's code the data node that will be an element of the tree. So we will start with this class called data node, and then we're going to have to decide what the name of the key will be. We'll just call it key, and we're going to make it an integer type. And that is the value that we will use to populate and expand our tree as we add nodes to it. So this will be int, or let's make it private here. So let's go ahead and do this, private int key, okay? And then let's have some sort of a payload. Now, what we would want in that node is not just the key, but what is it you're storing in there? Now, that could be the integer key itself. Then you will have to leave this one alone. Otherwise, if you have a different payload, let's say a bunch of names or something of that nature, or a name, then you can have something like this, private and string. And we're just going to call it data for now. So it could be anything. It could be a city. It could be anything of type string. If it's a number, we can convert it back. So we have some flexibility there. Okay, so we have these two elements. Now, for the data node, since this is going to be part of a binary tree, we also need the left and the right to point towards the next element. So we're going to do, and it will be a data node type, and we're going to have the left side. And by the way, let's go ahead and do it also private. So we'd like to encapsulate all this. And we're going to do the same thing for the right. So private, data node, right. Now, the way they are, we'll need a constructor to set the key and the data. We're not going to set the left and right automatically. As soon as you create a node, those will be null. Okay, so here's the constructor, public, and it will be data node. And let's make it an overloaded constructor where we supply it with a key and we supply it with data. And it will simply assign this dot key with a value of key. And same thing with the actual data that is part of the attribute will be equal to the data supplied by the parameter data, right? Or the argument. So that's that part. So that's the constructor. So let's write up here what we're doing. This is our constructor. Let's do it here. Oops, sorry about that. This would be our constructor. Okay, and this here will be our attributes. Okay, so now what we would like to do is set up our mutators, right? So, and our accessors. Let's start with the accessors actually. So let's go ahead and do accessors. What we would like to get is possibly print the actual data node itself, the content. We could do that with a toString. Let's start with that. So public, just in case we do a print statement with the node itself or the object node of type data node. And let's say this returns a string. We're going to call it toString. And this will simply return a combination of the key and the data. So we could have something like this, key plus key plus the data and that's what it would return. Okay, how about accessing the left and the right. Okay, so we're going to need that to see if the left and the right are null or not as we move and traverse, for example, the tree. And how would we do that? So public, and it will be a data node that we will return. Now, if it is null, then it will return a null object. And this will be get, and we're going to do a left, and we'll simply return left. We're going to do the same thing with the right-hand side, or the right node. And we're going to call it get right and return right. As you can see here, it's doing it for us. Let's just make it consistent on how it will be written up. There you go. Okay, so what else can we do? We can get the actual key itself, right? So that could be important because then we can compare some node's key to a particular key, right? So for that one, public int, and we're going to do a get key, and this will simply return the key. Okay. How about if we wanted to return just the data? Can we do that? Yep. Public and string, and that would be get data, and simply return data. By the way, we can go back here. Instead of just saying key here, we could say get key if you want as a method, and here get data as a method. So it will return that value over here. Good. All right, so let's see if we missed anything. So we have all of our accessors. Let's think of our mutators now. So mutators, those will allow us to alter, for example, the right and the left. But at any given time, we call any of these mutators, we would like to get a data node object back. So public data node set, and this time we're going to set the key maybe, or let's see here, we could do set data, and we're going to supply it with a key, int key, and string data. And unlike the constructor, we're going to be returning a data node reference. So similar to constructor, this dot key equal key, and then this dot data will be equal to the data we're supplying, but we will be returning a reference to the object. Okay, how about the right and the left? Okay, we can do that. So public data node get left, or get left node, or whatever you want to call it. And this one, I'm sorry, we're doing a set here, so set left, and it will take a data node left argument, and our left, or this dot left, will be equal to the left object we supply. And we have to return a reference to the object. We're going to do the same thing with setting the right. So public data node set right, data node right, and this would be this dot right will be equal to right, and then we'll return a reference to the object. Now, I think this will do it for us. Let's see here. So we have our mutators, we have our accessors, we have a constructor, and we have our attributes. Okay, so the next video, we're going to look at the class binary tree, which will implement data nodes for us and allow us to add these data nodes into a tree structure. I will see you then.